All right, hello, hello, hello. This is the second notes video for reaction types. This time we're actually going to be talking about the kinds of reactions. There is a bunch of stuff that is not on screen right now, so I want you guys to go ahead and write down number 1 and number 2 here, composition and decomposition, and I will step out of the way and let you write that down. But first, you are also going to want this worksheet. Okay, it is okay. This says worksheet 4.4a. This is actually linked as worksheet 4.4b because I realized I needed to put the vocab as a so that stuff is straight. So yeah, this is worksheet B because this is video B. So yeah. Go ahead, write down comp and decomp. All right, I'm going to assume you have. And we are going to go ahead and talk about these. Now, composition, first off, has another name. If you have an old person as your teacher, they may call it at some point synthesis. Synthesis is the old name for a composition reaction. Okay, both words mean putting together or assembling. Okay, it's collecting a bunch of stuff and making one thing out of it. Okay, so we're going to put in several things, but we're only going to get one out. Okay, so the thing that's going to make composition reactions stand out is there's only going to be one product. Multiple reactants, but only one product. I'm not going to bother with these last two statements. Okay, if you know, you know. If you don't, I'm not going to take the time to explain this today. Number 2 is decomposition. Now, the prefix DE, or D, means the opposite, or undo. Okay, so if it's the opposite of composition, then composition, which has one product and two reactants, is going to have one reactant and two products. One thing goes in and several come out. Okay, so in this we're putting something together. In this we're breaking things apart. Now I want to shift gears for a second to the worksheet that I pointed out a moment ago. So this is the worksheet that I showed you that you're going to need. So we're going to do reactions A, B, C, and D together in the video. But first, I'm going to zoom this in because I want to talk about reactants, products, and compounds. So I'm going to pause this, do some finagling here, and then we'll get back to it. All right. Now, first off, let's talk about formulas. So what we're talking about now has nothing to do with any of these blanks here. Okay? Formulas, where one formula ends and the next formula begins. A formula is a chemical equation, okay, or a chemical formula. It might have just one element in it. It might have multiple of that element. It might have several different elements and different numbers of each. When we were counting, we were looking at chemical formulas. Okay? When we were identifying bond types, we were looking at chemical formulas. So you need to be able to look at a chemical equation and figure out how many formulas are in it. So here, a chemical formula cannot include a plus sign or an arrow. So Cu is one formula. O2 is a separate formula. CuO is a third formula. So there are 3 formulas in reaction A. B also has 3, one over here and 2 more here. C and D have 4, Fe, H2O, H2, and Fe2O4 for C, and then D is AsCl3, H2S, As, I think that's 2S3, and then HCl. Okay, those are your different formulas. Some of these formulas are reactants. Some of them are products. The way you tell the difference between the reactants and the products is which side of the arrow it's on. So there are 2 formulas behind the arrow. So there are 2 reactants. There is 1 formula the arrow is pointing at. So there is 1 product. Here, so I'm going to do B. I'll just go ahead and do all these. Okay, so H2O is the only thing behind, so there's one reactant. H2 and O2 are the only two that are the two that the arrow is pointing at, so there's two products. Then Fe and H2O are the two reactants on C. H2 and Fe3O4 are the two products on C. Then here again we have two reactants and two products, so 2 and 2. Okay, that's reactants and products. Now, when we are looking at composition or decomposition, we only care about reactants and products because composition, and you should write this up here, composition must have one product. Okay, it's a composition reaction if it has one product. None of the rest of these have one product. They all have two. So composition must have one product. If it has one product, then it's going to be a composition reaction. Decomposition is the opposite. It's got one reactant. So if it only has one reactant, then it's a decomposition reaction. So between the first four here, there is one comp and one decomp. A, because it has one product, has to be decomposition. So over here in this blank, we're going to put CP, because CP is the abbreviation for composition. Okay, B is is decomposition because it's only got one reactant. Okay, you should have written a 1 here. So there's only one reactant. Products don't matter. There's one reactant. It has to be decomposition. Okay, so we'd put DCP in the fourth blank for this one. Not the third blank, not the compounds blank, but the actual fourth blank that's off the edge of the page here. Okay, now pause this and go through and identify all of the composition and decomposition. I'm going to tell you, before you pause it, that there are 7 total. Okay? There are 7 reactions that make up comp and decomp. So pause this, find those. I'm going to, well, I'll just say go ahead and pause it. All right, I'm assuming you've done that. There are 4 composition reactions and 3 decomposition reactions. So I'm going to list these off. Composition is going to be A, H, N, and V. A, H, N, and V are composition. There are 3 decomposition. Those are B, G, and J. Okay, B, G, and J. Now, we're going to switch and talk about double replacement for a moment here. So, go ahead and write down double replacement. Don't do combustion yet because not all of it is there. So, go ahead, pause this, write down double. All right, you're going to see me done that. In a double replacement reaction, you have 2 compounds on your reactant side. Okay, so those 2 compounds, what they're going to do is they are going to trade their anions. Okay, that's why it's called a double replacement, because double, 2 compounds are replacing their anions. Okay, so we'll have 2 reactants and 2 products, 2 things in, 2 things out. And all 4 of those have to be compounds because the 2 reactants, when they trade their anions, they're still going to be compounds. Okay, now, by the way, all 3 of the next 3 that we're going to talk about have 2 reactants and 2 products. Okay, single replacement, double replacement, and combustion all have 2 reactants and 2 compounds. So what we have to do to tell the difference between them is look at the number of compounds. Okay, so let's go back to the worksheet. To figure out the number of compounds, you have to determine whether it's a compound or not. So each of the 3 formulas here, we have to determine whether it's a compound or not. Well, what makes it a compound? In order to be a compound, it must have 2 or more elements present. Okay, 2 or more elements present in the same formula. So Cu is one formula. It's only one element because the U is lowercase. So this is only one element. This is not a compound. This is what we call an elemental because it's a single element by itself. Not a single atom, single element. Now this one is also a single atom, but that's not always going to be the case. O2 is another elemental. This is not a compound. There's only one capital letter. There's only one element, oxygen. So this is also not a compound. CuO, we have 2 capital letters. We have copper and we have oxygen. So this is a compound. So there is one compound on A. So obviously, A can't be double replacement. But we already knew that because we already said that A was composition. Okay, B also only has one compound because this is 2 elements, but this is only 1 and this is only 1. So this is also one compound. So also not double replacement. But again, we knew it was decomposition already. C, though, we haven't identified yet. So C and D, one of these has to be a double replacement reaction. So Fe, is Fe a compound? No, there's only one capital letter. So we can't be double replacement. We have already determined that it is not double replacement. But we're going to, go ahead and figure out how many of these are compounds because we're going to need it here in a minute anyway. So Fe is not a compound. H2O, that's a compound. That gives us 1. H2, not a compound. Fe3O4, that's a compound. So there are 2 compounds on C. And on D, we have ASCl, we have H and S, we have AS and S, and we have H and Cl. All 4 of these are going to be compounds. So we have 4 compounds here, so this is going to be 4. And D is double replacement, so we're going to write Dr off over here, off the edge of the page, where it says reaction type. So how did we identify that? Well, double replacement has to have 4 compounds. Write that right here. Double replacement must have 4 compounds. Everything has to be a compound. But it also has to have 2 reactants and 2 products. Don't forget that. So if you're wanting to write that, a good way to do that, 2R, 2P, 4 compounds, C. Okay, has to have 2 reactants, 2 products, and all 4 of these have to be compounds. Okay, now let's go back and talk about combustion. There we go. Okay, so combustion, wait, I'm getting ahead of myself. Write this first. Pause it, write it down. Okay. Combustion reactions, again, 2 reactants, 2 products. However, this time the reactants must be something specific. Okay, so there's something you need to jot down. And I would jot this down on this worksheet. I would do it right here in this big empty spot right here. Okay, this big spot. You need to write down that organic means carbon and hydrogen. Okay, organic means carbon and hydrogen. Okay, that's important because one of the reactants in a combustion reaction has to be an organic compound or an organic molecule. So that molecule has to have carbon and hydrogen in it. It could have other stuff too, but it must have both carbon and hydrogen. CO2, not organic. There's no hydrogen. H2O, not organic. There's no carbon. It has to have both carbon and hydrogen in the reactant, or in that first formula. Well, in one of the formulas. The other reactant has to be O2, oxygen gas. Okay, so your tip-off, your note that you're putting here. Here it was 4 compounds. Here, for combustion, the 2 reactants, because it has to have 2 reactants and 2 products, the 2 reactants have to be organic and O2. Okay, must be organic and O2. Now, none of these 4 have anything organic in them. There is no organic molecule on the first 4. So we're going to scroll down to reaction M, because reaction M is organic. Okay, C3H8, that's organic because it is carbon and hydrogen. So that means this could be combustion. Just this does not make it combustion. It also has to have the second reactant, or the other reactant, be O2. So if it's carbon and hydrogen, an organic molecule, and O2 as the reactants, then this is going to be combustion. Okay? So, this has to be a combustion reaction. So, for reaction M, off on the edge of the page, it's combustion, CB. Okay? That's how you identify your combustion reactions. Now, by process of elimination, C must be single replacement. However, there are 2 kinds of single replacement reactions. There are cation replacements and there are anion replacements. So let's talk about the difference between those. Okay, so I'm going to step over here. You need to write down everything between here and here. So go ahead and pause this. I have to be able to scroll this far. There we go. Okay. So now go ahead and pause this and write all that down. And I'm going to assume you've done that, and I'm going to go through this now. Okay, so double replacement, this one over here, is 2 compounds trading their anions, or having their anions replaced. In single replacement, there is only 1 compound on the reactant side, and that compound is having either its cation or its anion replaced. Thus the term cation replacement or anion replacement. So there are 2 ways this can look. You'll either have a reaction like this or like this. Now the difference between these is that one of them is a cation, the other is an anion. The way you can tell, if you look at the elementals. So in this reaction, we have NaCl plus K and KCl plus Na. K and Na are our elementals because they are not bonded to anything. They are by themselves. Okay? These are both metals. Metals form cations. So this is a cation replacement because the 2 elementals are metals. By the way, hydrogen here acts as a metal. So if you have hydrogen in either of these spots, H2, that's going to be a metal. Okay, it's going to act as a metal. Okay, remember we said hydrogen sometimes acts as a metal. Here it's a metal. In bond types, it's a nonmetal. In reaction types, it's a metal. In bond types, it's a nonmetal. In reaction types, it's a metal. I might have said that backwards. Okay, here it is a metal. Hydrogen acts as a metal. Now, this other one down here, we have bromine and chlorine as the elementals. Those are nonmetals. So this is an anion replacement instead of a cation replacement. Yeah, that's pretty much it. So I'm going to clear this, and let's go back to our worksheet. So in order for it to be a cation replacement, again, 2 reactants, 2 products, but there must be 1 elemental on each side. 1 elemental's product, 1 elemental reactant. On this, both must be metals or hydrogen. Anion replacement, those 2 elementals must be non-metals. Okay, and we distinguish between cation and anion with Sr plus or Sr minus. Sr because these are single replacement, plus for cation, minus for anion. Okay, so you need to go through and identify all of these. Okay, but first, let's figure out which one C is. So C is obviously single replacement because that's all that's left. Well, is it a cation replacement, though, or is it an anion replacement? Well, we have iron and hydrogen as our elementals. Iron is a metal. Hydrogen pretends it's a metal when we're doing reaction types. So that means this is a cation replacement. So in this case, we're going to call it a cation replacement. So the reaction type off on the edge of the page is Sr+. Now, I meant to have you go through and identify each of these as you went. I'm going to tell you you need to do that. I will tell you that there are 5 double replacements, 7 single replacements, and 6 combustion reactions. There are more cation replacements, or more Sr+, than there are anion replacements, Sr-. Okay, so go through this worksheet and I figure out all the reactants, all the products, all the compounds, and identify all the reaction types. Okay, you can print this off Canvas. It is worksheet 4.4b. And you should also do the vocab worksheets that are on Canvas. That's 4.4a for the first video, and 4.4c, which is going to have vocab related to the reaction types. So, yeah, that's pretty much it. I'm going to stop this here because 22 minutes is getting a little beefy. Have a wonderful whatever, and I will see y'all next time.